Hello everyone. I have the SoMove drive commissioning software open. It's a product made by Schneider Electric. It is very good. I use it quite a bit. And I want to demonstrate the scope functions in the software. Now we know that we can monitor inputs and outputs. We can parameterize, we can set all of our parameters and control functionality for the motor. We can have fault management set up on the motor. We can look at errors. We can view the latest errors through error detection, the last 4 faults detected, and so on. We can go into monitoring and we can run the motor, and I will do that briefly. And we can monitor all of the variables shown in this list: current, frequency, voltage, motor thermal state. We can view the HMI. You can adjust the speed, you can see that change. You can view the faults on the HMI also. So it's quite powerful, but there is another tab that is also quite powerful. It's the scope tab. Now in the scope tab, you're allowed to choose from a numerous amount of variables. I have 4 chosen here. I have output frequency, motor current, the mains voltage, and the motor thermal state. So that's the motor thermal state is the overload percentage current relative to the what's set in the motor parameter setting for the motor current. Now there's a lot more that we can add. If I click on add, we have a whole list of other variables that we can monitor using the scope, but I just want to keep it fairly simple. I want to watch that motor thermal state to see if it exceeds the values that's set in the software. So we can choose different channels, and we can also set up the duration. So we can actually record up to 3 days. I have it set for 1 minute. So if you had a problem with a motor loading, or you had an input voltage issue where you had voltage that was dropping below your nominal value for your motor and drive system, or you had surges, you could view that in the oscilloscope. Now we have options on the trigger. The trigger has a lot of options. You have a standard option and you have an expert option. And what the expert option allows you to do is set up an on and off trigger. So a start stop, so you can have one event that will start the scope and one event that will stop. Then you can make it repetitive. So what I'll do is I'll just go back to auto, and I am going to set the trigger to turn on at a frequency based on the output frequency. So if you go up to the channels that we are recording, we have an output frequency, which is the blue one. And what I've done is I have set the trigger to auto mode, and the variable that I have chosen is the output frequency, and I have set it to 1 Hertz. So as soon as we are running at a level of 1 Hertz on a growing edge, so that's not when it's above 1 Hertz dropping, it's when it's at 0 to 1, it'll turn on and start recording. And you can adjust this. This is adjustable. You can adjust your trigger based on any one of these events in this list. So we'll just leave it set up as is. Now there's 2 ways when you first initiate the scope. So I am going to initiate the scope now. So you take your mouse, and there's a little play button right here where it says start trace. So you hit the start trace play button, and it says waiting for trigger. And I'll do this 2 different ways. I can manually just force the trigger and start recording, so I'll do that. Now the drive's not running, so you won't see any data on the screen, but I'll start it recording. It's going to record for 60 seconds, and I will turn the motor on. So the brown trace is the mains voltage, and the blue trace is the output frequency, the green trace is the current, and the red trace is the motor thermal state. I'll start it. So I just started the drive running, and you can see the blue trace accelerated. It's on a 3-second ramp up to, it's running at about 53, 54 hertz. I'll take that up to 60, and then I'll overspeed it. I'm going to go above 60, and you should see the current start to go down. And you can see at this intersection right here, I am going to double the frequency on the motor from 60 to 120 hertz, which will cause the current to go down, so we can view that on the scope. Now what will happen is it'll time out. So the trace is done. So this is captured now, and I am going to stop it, and I'll set it up for an auto trace. Now if I want to get rid of the trace that I have, I can save it, I can export it, I can just delete all traces rather, by clicking that X, and I'll clear the screen. Now what I'm going to do is I'm going to set up a bit more acceleration so we can view the current and the frequency scaling together. I'll set this for 10 seconds, and I'll set the decel for 10 seconds also. So I've changed the ramp. I'll go back to scope, and I'm going to hit the play button and just wait for the auto trigger to initiate. Instead of forcing the scope, forcing the trigger is a great way to force the scope to start recording. But right now I have it on auto, so whenever the field event occurs, in this case it's me pushing the button and starting the drive running, and as soon as it hits 1 hertz, it will start recording. So if you watch the screen, you will see it. Now one thing to note about these traces is they auto scale, so they jump around quite a bit. But right now the brown one, second from the left, which is the line voltage, it's only showing 1.2, but it's going to have to scale up to 120. So I'll go ahead and hit the forward button, and it's going to run. And we're on a 10-second ramp, so the blue trace will take a little while to ramp up, and it's going to ramp all the way to 120 hertz, so you'll see it auto scaling. And once the frequency hits 60 hertz, as we saw in the last trace, the current will start to drop because of the inductive reactance in the motor is increased. Therefore the current will start to decrease, therefore the torque will go down. I'm going to hit the stop button now, and you see the blue trace coming back down. You can see some surges in the voltage. And we'll have a little evaluation on this. Now, you can look and you can view the actual thermal state, and you can see it stair-stepping up here and then flatlining, and then it starts to stair-step up again as the current increases. That's interesting. I'll do one more quickly, so I will stop the scope and I'll clear the screen, and we're going to look for a voltage spike. And I have a variac attached to my power supply, and I'm going to simulate a voltage spike here, or a surge in the voltage, to see if we can capture it on the scope. So I'll start another trace, so I'll hit start, and then we're in auto mode, so I'll hit the run button on the drive, and we'll just let it ramp up. And then we have to keep our eye on the mains voltage, which is the brown colored one. Once we flatline, we're around, yeah, so 120 is right here. So we're bouncing around 120 to 119. I just gave it a shot up. I'll just give it another one. And you can see these two spikes right here, this one and this one. Those are voltage spikes. They went as high as 134 volts. So if you were having issues with the power supply and you suspected there was a problem coming through, but you couldn't pinpoint it, you could set the scope up for 3 days of trace on an old laptop computer hooked up to your drive using SoMove, and away you go. You might be able to find some issues, or it could be a load that's changing, that's causing current surges in the system. So that's using the scope. I was going to say oscilloscope, but it's using the scope in the SoMove drive configuration software. It's pretty cool.